I'm going to talk about cones. I will assume that you're familiar with the basics of circles, including the formula for the area and the circumference of circles. I'll also assume that you're familiar with the basics of pyramids, including the volume formula for a right pyramid. All right? So let me now describe what a cone is. A cone is a three-dimensional shape that includes a circular base. So let me draw a picture of a circle. And the rest of the surface of the cone narrows to a point referred to as the vertex above the center of the circle. All right, so there is a picture of a cone. You see the circular base on bottom, and then you see the vertex point at the top. You can have cones where the vertex point is very high relative to the size of the circle. Something like that. You can have cones that have vertex points very close to circles relative to the size of the circle. Let me make an example with a vertex point closer to the center of the circular base. All right, so all of those are examples of cones. Now I'd like to discuss the formula for the volume of a cone. So give me a minute to make a picture of a cone again. So the formula for the volume of a cone is exactly the same as the formula for the volume of a right pyramid. Okay? The formula for a right pyramid is 1/3 times the area of the base, let's denote that by capital B, times the height, let's denote the height by H. Okay? Now, why would a cone have the same volume formula as a right pyramid? Well, remember that the base of a right pyramid can be any polygon. If the base is a regular polygon with a huge number of sides, imagine a regular polygon with 100 sides or 1,000 sides or even 1,000,000 sides. If you can imagine that, as the number of sides of that regular polygon increases, the polygon becomes more and more like a circle. All right? So in a sense, a cone is a pyramid, but it's a special pyramid that has a base that's a polygon with a huge, unimaginably large number of sides. Okay? In fact, you might even say it has an infinite number of sides. So for that reason, we use the volume formula for a pyramid. Now, we can denote the volume in terms of the radius of the circle. Let's say that the cone in my picture has a radius r and a height h. So give me a minute to label my picture with those variables, those quantities. So a radius r and a height h. So the area of the base, to find that, we will use the formula for the area of a circle, which is pi r squared. So the formula for the volume of a cone can be written as 1/3 pi r squared h, where r is the radius and h is the height of the cone. All right? Now I'd like to talk about the surface area formula for a cone. So once again, let me make another picture of a cone and we'll discuss. So the surface area must include the area of the base of the circle, right? So that we will use the area formula for a circle. What about the rest of the surface of the cone? So to see how we're going to figure out that area, imagine that we had a paper cone, all right, and let's say that we removed the base, so there was a hole there, and so like the covering for an ice cream cone, that's a paper cone without a base, all right. Now suppose that we cut that paper and we flattened out that paper so that it laid flat on a table. You might want to do that to convince yourself that the surface of the cone that does not include the base will flatten out to this shape. Give me a minute to make the picture. Okay, it'll look something like that. Now, when I see that figure, I think about an old computer game called Pac-Man, and there was the character in it was shaped like that, and it was called Pac-Man. So the blue lines on my little Pac-Man picture are where I cut the surface of the cone on the left there. Okay. So if my original cone had a radius r and a height h, let's see if we can finish finding the surface area formula. So let me label here the radius r and height h first. All right, so the area of the black edge on my Pac-Man shape is going to be the same, or the length, excuse me, of the black part on the Pac-Man shape is going to be the same length as the circumference of the base of the cone. So that's going to have a length 2 pi r. That's the formula for the circumference of a circle. And the radius of that circle is going to be the length of that blue cut in the original cone. Can you see that in the original cone I could make a triangle with a line segment from the vertex to the center of the base, a right triangle that has a height of h, that has the long leg length of h, it has the short leg length of r, and the hypotenuse is, let's call it S, where S, using the Pythagorean theorem, that's equal to the square root of r squared plus h squared. Okay? So all of that is to say that the radius of, or the length of those blue line segments in my Pac-Man shape, both of those have a length S. Okay, so to find the surface area of the cone, we're going to have to add the area of my Pac-Man shape to the area of the circular base. All right, so let's see if we can do that now. So if the Pac-Man shape was not missing that little slice there with the blue line segments, we could just say that the area is the area of a circle with radius s. All right, that would be pi s squared. But now, from that, to find the correct area, we're going to have to subtract the area of that little missing pizza slice shaped piece. All right, so how do we find the area of that piece? Well, that piece is going to be a fraction of the area of that little pizza slice is going to be a fraction of the area of the entire circle. Okay, that fraction is the same fraction of the circumference that this little purple segment here is. If this little purple segment was a quarter of the circumference, then the area of this little pizza slice is going to be a quarter of the area. Okay, that's what I'm getting at. So let me see if I could make that a little better. All right, so what is the fraction of the entire circumference that purple arc contains? Well, the length of that arc is the circumference of the circle with a radius s minus the length of the black part, which is 2 pi r. Okay? And that divided by the total circumference of a circle of radius s, that's the fraction of not only of the circumference that purple arc is, it's also the fraction of the area that pizza slice shaped part is. Okay, so we're going to take this fraction and multiply it by the total area of a circle of radius s. Pi s squared. Now, that whole expression there is what I'm going to subtract from pi s squared, and then I'm going to simplify it. Okay? So, let's go ahead and do that. Pi s squared, and let me do some simplification here. So the pi's cancel, the 2's cancel, and so I have, I can also take the s and divide it by one of the s's in the s squared, so now I don't have a fraction anymore. So I've got now pi s squared minus what's left of that expression there where I did the cancellation. So s minus r times pi s, and that gives pi s squared minus, if I distribute the pi s now, minus pi s squared plus pi r s. So the first two terms cancel, and I'm left with pi r s. And I add that to the area of the circle, and that gives my surface area formula for a cone. So let me write that now. the surface area formula for a cone is the area of the circle, pi r squared, excuse me, plus that's pi r s. Okay, where s is equal to the square root of r squared plus h squared. So you can also write it, you can also substitute that radical for s if you like. All right, so there's our surface area formula. Now let's do some examples using the volume and surface area formulas for a cone. Let's start with a cone with a radius of 3 inches and a height of 4 inches. So give me a minute to finish my picture. So a height of 4 inches and a radius of 3 inches. Let's determine the volume and the surface area. For the volume, I'll do 1/3 pi 3 squared times 4, and that will give 12 pi cubic inches. For the surface area, I'll do pi times 3 squared for the base, plus pi times 3, and now I have to figure out what s is. I can use the square root of 3 squared plus 4 squared. All right, and then so now I just simplify that. So 9 pi plus 3 pi times, let's see, the square root of 9 plus 16 is the square root of 25, which is 5. So now I have 9 pi plus 15 pi, which is 24 pi square inches for the surface area. Okay? Now I'd like you to do an example. So once again, give me a minute to make a picture. All right, so I've drawn a picture of a cone with a radius of 5 meters, and notice that I haven't given you the height of the cone. I've given you what's called the slant height of the cone, and it's 13 meters. That's the distance from the vertex to a point on the edge of the base. Okay, so find the volume and surface area of the cone. Pause the video and do that now if you like. All right, so I'll go ahead and work it out as well. So to find the height, I'm going to have to make a right triangle such that the hypotenuse is the slant height. So if you could imagine a right triangle with the vertical line segment going through, or starting at a vertex and going down to the center of the circle. So we'll call it H, call this 13, and then the short leg 5. So you can use Pythagorean theorem to determine that h is 12. Okay, so I worked it out for you there to see how you can derive that h is 12. So all of that means that the volume is 1/3 times pi 5 squared times 12, which gives 4 times 25, which is 100, so 100 pi cubic meters. For the surface area, we'll include the area of the circle. And then for the rest of the area of the surface area of the cone, we will include pi times the radius times the slant height. So let's see, that gives pi, if I factor out the pi times 25 plus, and then 5 times 13, that's 50 plus 15, so 65 plus 25 is 90 pi. Gives, or the 25 plus 50 plus 15 gives 90, and then I multiply that by pi, so I get 90 pi square meters for the surface area. All right. Now, let me do one more problem. Let me have you do one more problem. Okay, see if you can solve this one. A cone and a right pyramid with a square base have the same height and volume. Find the side length of the square base of the right pyramid in terms of the radius of the base of the cone. So the cone and a right pyramid with a square base have the same height and volume. Find the side length of the square base of the right pyramid in terms of the radius of the base of the cone. All right, so pause the video and work that out now if you can. All right, so I'll go ahead and work it out. It never hurts to make a picture. So we've got a cone, and now we've got a pyramid with a square base. And the height of this pyramid is the same as the height of the cone. All right, so something like that. And let's give the square base of the right pyramid give it sides of length s, and let's give the cone a circular base with radius r, and let's give both of them a height h. Give me a minute to finish my picture. All right, so the volume of the cone and the pyramid are the same. So 1/3 pi r squared h is equal to 1/3, and the area of the square would be s squared times h. And so we want to solve for s in terms of r. I can cancel the 1/3 on both sides and the h on both sides. So I'm left with s squared is equal to pi r squared. Now I can take the square root of both sides, and I will get s is equal to the square root of pi times r. Okay, so the side lengths of the square base must be bigger than the radius of the cone by a factor of the square root of pi. That's approximately 1.8 times r. Okay, so about 80% bigger. The side length of the square is about 80% bigger than the radius of the base of the cone.